relative velocity. Relative velocity. Now let me take this as the point origin, and a particle has moved uh, from here. I am considering a distance means x naught at t is equal to 0. This is the position of the particle, uh, of a particle at t is equal to 0. This is x naught, this is the position, and after time t, let its position be xt, that is at time t its position be xt, and this is moving with a velocity va. The particle is moving with a velocity va. Now, and another particle, uh, it is let this be xa, and this xa, a particle, another particle xb at t is equal to 0, this t equal to 0, let this be the position, and after time t, let the particle position be at t, this, and the particle is moving with velocity vb. So your xt, xat will be equal to xa naught plus vat, and your xbt, this will be equal to xb naught plus vbt. Now this is equation 1. Equation 2, 2 minus 1, we get xbt minus xat, that is equal to xb0 minus xa0 plus vb minus va into t. So this vb minus va, this vb minus va, this is what we have, this is the main point. This is vb minus va, this is, what is this? This is as seen from object A, as seen from object A. Object B has a velocity, vb minus va, as seen from object A. Object B has a velocity this, or you can say velocity of B relative to object A is velocity of B relative to object A is Vb minus Va. This is about relative velocity. Now, if case 1, if your Vb is equal to Va, then what happens? Vb minus Va is equal to 0. So here xb naught minus xa naught will be constant. This will be remain constant. In case 2, if Vb is less than Va, then what will happen? After some time, object A will after some time object A uh, 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 means that is after some time what will happen after some time object A will overtake object B. Now case 3 will be what will be case 3 in case 3 in case 3 if your VB minus VA magnitude of you can say if magnitude of VB minus VA is greater than VB and VA. If the magnitude of VB minus VA is greater than VB minus VA, then um, uh, then for either of them either for observer um, uh, in uh, um, if magnitude of VB minus VA greater than VB and VA, then for both the observer in VA or VB will appear to move very fast. That is, if the magnitude of VB minus VA is greater than VB and VA, for both the observer in VA or VB will appear uh, to move very fast. So this is all about relative velocity. This is all about relative velocity, that is if magnitude of this is greater than VB for both the observer in VA or VB will appear to move very fast. So this is about relative velocity. Now now my third question is in figure m1 is equal to 5 kg and m2 is equal to 2 kg and F is equal to 1 Newton. Find the acceleration of either block and then describe the motion of M1 if the spring breaks but F continues to act, continues to act. Now here again here again the figure is given to you pulley M1 into, this is the force F, this is the force F. Now here there are two systems, and here the tension is T, here also tension is T, because same tension, because I am considering the pulley and the string to be light. So now let us consider that this is moving downward, acceleration will be the same. So in this first system, we get first system, that is F minus not F, that is F plus m2g, these two forces, one is this force and another is the m2g force is acting downward, minus T, this will be equal to m2 into A, and for this system this will be T minus F plus m1g, because here also the weight is acting downward, m1g, that will be equal to m1a. Now what I am going to do, this is equation 1 and this is equation 2, so I am going to add 1 plus 2, T cancels out, so F plus m2g minus F minus m1g is equal to m2 minus m1 into A. F cancels out, so your G m2 uh, minus m1, that is equal to, here also this will be m2 minus m1, so into A. Now I have a problem here, that this cancel out, your acceleration is I'm getting G. Here I'm getting G, that is acceleration is the same, so since acceleration is the same, so here, I have to add, I have done a mistake here, so something wrong has come out here. 1 plus 2, so this dt cancel out, F plus m2g F plus m2g, this is okay, minus F minus m1g, that is equal to m2 plus m1 into A. So here G m2 minus m1, this will be equal to m2 plus m1 into A. So G 5 minus 2, 5 plus 2 A. So 3G by 7, this will comes to A. For round up I am taking G is equal to 10. I am taking G is equal to 10 meter per second square. So 3 into 10 divided by 7 is equal to A. So 30 divided by 7, 7 fours are 28, 2.0, 7 twos are 14. So it comes out to 4.2 meter per second square is equal to A. This is your answer. Now when we divide it, this 7 7 8 is 56, so this comes out to be, say, 4.28 meter per second square is equal to A. You can roughly say 4.3 approximately is equal to A. This is your answer. This is your answer. See, this is another question. Let m1 is equal to 1 kg, m2 is equal to 2 kg, and m3 is equal to 3 kg in the figure. Find the acceleration of m1, m2, m3. The string from the upper pulley to m1 is 20 centimeter. This distance is 20 centimeter. When the system is released from the rest, how long will it take before B1 strikes the pulley? Now here you see, this is the question given to you. Let me consider that this is moving in a downward direction. So here in this stage it is moving in a downward direction. At the same time here this is moving upward and this is going downward, but the whole system at the same time is going in downward direction. Since the pulley and the string is very thin, so this here tension T, this tension T, both sides will remain same, and so here tension will be 2T and also 2T. Here acceleration A and acceleration A, and the whole system will move downward with acceleration A. Let the here in this side be acceleration A1 and this side also acceleration A1, but both are moving downward, but here the acceleration will be A1 minus A and here the acceleration will be A1 plus A. So because the both the whole this system is moving downward, at the same time this is moving up and as well this is moving down, so here the acceleration both will be the same, at the same time this is moving downward, so here the acceleration will be A1 minus A and this here side this will be acceleration will be A1 plus A. And so now when I'm going to, for this system, I'm taking this system here T minus m to g because it is going upward, so m to this, and here so this I have put the value of m and I've got this answer. For this system here it is going downward, so this is m3g, means this will be force will be weight will be m3g, and here the force will be m2g. So putting the value of, I got this equation, and for this system it is going upward, so 2t minus this is equal to m1a. Putting the value of m1, I got this equation. Now first of all I'm going to do one thing, that is 1 plus 2. If I add this 1 and 2, if I add this, I get g is equal to 5a1 plus a. You can see this tt cancel out, g 5a1 plus a. And from equation 2, this is equation 2, I multiplied it by 2 and I got this equation 5. Now what I have done, that is I have taken this equation, I have add these two equation, this equation 3 and 5, I have add this to equation 3 and 5, I have add this to equation. When I add these two equation, I get 5g is equal to 6, a1 plus 7a is equal to 0. Now with this equation, I have this equation and this equation, I have taken these two equation, and by the elimination method I have found a1, this is comes out to 2g by 29, and a by the elimination method same, I have found 19g by twice a. Here a1 plus a will be 21g by 229, and a1 minus a will be 17g by 29. These are in downward direction, these are in downward direction, this are direct right direction, and this is in upward direction, this will be in upward direction. And the time taken will be as is equal to, since initial velocity is 0, so a is this much, so t square, when I calculate t, it comes out to be 2.5 seconds. So this is your answer.